Hello everyone. I think the audio is not recorded up to 14 minutes. After that, the audio is fine. Then after I have explained the same thing, not in this much detail, but a little bit about this up to this 14 minutes again in the later part. Now coming to Hashmap, like Hashmap stores data in the key value pairs that will use the hash function to compute storage location. Here insertion, deletion and access operations take O1 time on average, but ON time in the worst case as due to collisions. Hash maps are used in databases and caching systems. The advantage is very fast, like average lookup time, while the limitation is like unordered storage and collision handling overhead. Now coming to the implementation, like I have defined a node for the hash map. Like this node will be storing that key and value pair, and it will be storing the pointer to the next node which it wants to point to, and that is then that is initialized as next. And I am creating here a table of size, the size is initialized to 10, a table of size 10, where it will be storing the addresses of that addresses of the node. Okay, fine. Where it will store in the addresses of the node, particular node address, this table will be storing. Here initially they are will be null initialized to, and this is a hash function. This is a simple hash function I established. Like if I give a key, then it will be returning the hash value as key modulo of size. And coming to the insert operation, if I want to insert a particular key corresponding to this particular value, then the index will be like index will be generated using the hash map. There I will be passing this argument as key, then I will be getting the index. Then what I will be doing is I will be creating a new node where the new node will be storing that for the address for that particular newly generated node of the size. And what I will be doing is for the new node I will be assigning the key value, and will be assigning the key value and the value. And what I will be doing is I will be pointing this node dot next to that particular table index where I have seen, right? There I will be pointing. Now for example, at start it will be null, right? So now the new node dot next will be pointed to null, and what after that I will be doing is like I will be pointing this node, like I will be pointing this table index is that, right? There the address will store, right? That there I will be, then that address I will be pointing to this node. Now what will be happening is this table dot index will be storing this node address, and this node index will be null. Like that it continues. In this case what will happening is why it is like it will be avoiding the collision if the hash function returns the two same values as the index. To avoid collision, we are implementing this. And to delete a key in that, like again if a key is given, we will be calculating the index regarding that particular key, and we will be having a temporary creating a node that will be pointing to this table of index, and we will be making the previous like the previous thing, like a previous element to null, not the previous element. I initialized a pointer that is initialized to null. Like we will be doing for this temporary mean by the table dot index. Like if this temporary dot key, like if it points to that key, means exact key if it is matched, and if the previous element is also exists, then what we will be doing is, as we have seen in the linked list, the previous element will be combined to the this particular index next element, and this temporary element will be gone, means it is the key we want to delete, right? So we will be deleting that. Then if the previous element is still null, then what we will be doing is we will be directly pointing this table dot index to the next element that we want to delete, and here we will be freeing up that present key value. If the key value is not matched, then we will be updating the previous to temporary node, and the temporary to temporary next node until the key is fine. And to access an element, we will be having an index particular to that key, and from that key what we will be doing is we will be creating a temporary that will be again pointing the table dot index, and we will be iterating through that linked list here, and we will be seeing if that value is found. If the key is matched, then we will be returning this temporary dot value. If not found, then we will be iterating like temp equal to temp dot next temp, we will be iterating, and this is the thing. And coming to hash set, like a hash set like will be storing only unique values using hashing, like insertion, deletion, and lookup operations. Will take over time on average. And on, like insertion, deletion, that will take over and lookup on. In the on will be taking in the worst case, maybe due to it will be due to the collisions, it will take in on. Hash sets are used for duplicate removal, like and fast membership checking. The advantage is like enforcing uniqueness with fast access, while the limitation is that element ordered will not be preserved. Yeah, coming to the implementation now, creating the main difference is like in Hashmap, as we have seen here, we will be having the key, but coming to Hashset, they will be having no key, and we will be only having this value here. And in this node, we will be having value. Along with that, we will be having a pointer that will be pointing to the next node as seen, and same initializing the address array for this particular nodes. And the same as hash function I have been used, and to insert at a particular thing I have created that index using this hash function. Then after I have created a new node pointing to that new address allocation. Then after I'll be storing that value, and then after the same thing, like I'll be setting this where the address will be stored to the present created new node, and I'll be attaching that if any nodes are present earlier, then I will be attaching to that. Like main thing here happens is like that new nodes will be like the new node which have come, that will be stored at the start of the linked list, and the linked list will be going on like that. And coming to the deletion, like same I will be having this index where I will be getting from the hash function, then temp and previous, like I explained in the hash map. And the same thing happens here, instead of checking the key value, we will be checking key there. Here we will be checking value. And the same if temp, this is like in linked list, like deletion operation. If not, I will be setting it to directly to the present, not the present. For the present, the next value I will be setting it, and it will be freeing up that temporary node now. And if not, then I will be moving that previous to temporary, and temporary to temporary next, and checking if the value is contained in that. Then again I will be getting this index there, and then after I will be checking by through iterating. If they found that value, I will return as 1. If I would not found that value, then I will return as 0. And coming to average O1 access in hash based data structures, like it occurs in hash based data structures because a hash function will directly maps an key or value to a specific index in an underlying array. This allows insertion, deletion, and access operations to be performed in constant time on average without scanning all elements. The performance remains O1 as long as the hash function distributes key uniformly and the load factor is maintained. Then a collision occurs when two different layers produce the same hash index. Like collision handling is required to store both elements correctly. The most common collision handling techniques are chaining, like a linked list, which each index stores a linked list, or we may use tree of elements, and open addressing, where the algorithm searches for another empty slot using methods such as linear probing, like that. And the difference between a hash map and a hash set lies in what they store. A hash map stores value pairs where each key maps to a specific value. A hash set stores only values and does not associate them with additional data. Hash maps are used when data mapping is required, while hash sets are used when only uniqueness matters. Order is not guaranteed in hash-based data structures because elements are placed based on output of the hash function, not on insertion sequence. The internal arrangement depends on hash values, table size, and collision resolution, which can change as the structure goes and refreshes. In the previous video, I think the audio is not recorded, so I was justly so I'll just go into what I have talked there. Not regarding exactly what I talked there, just I'll be explaining the things. because the audio is not recorded there. And coming to array, it is like a data structure that stores elements of the same time in contiguous memory location. Because the memory is contiguous, an element and each element can access directly using its index. Insertion at specific index and deletion requires shifting elements and takes O(n) time, while accessing an element by index takes O(n) time. Arrays are used to store fixed size data such as like image pixels or sensor readings. The main advantage of an array is very fast access, and the limitation is expensive insertion and deletion operations. And coming to a linked list, it is a collection of nodes where each node contains data and a pointer to the next node. Nodes are stored in non-contiguous memory location, so access requires traversal. Like insertion and deletion at a known position take O(n) time due to traversal, and accessing an element also takes O(n) time. Like linked lists are used in playlist like that, and like in main dynamic memory allocation. The advantage is like flexible size and easy insertion or deletion once the position is reached, while the limitation is slow access and extra memory overhead for pointers. And now coming to the stack data structure, it's a linear data structure that will be follows like a last in first, or like whichever comes last that will be taken out first. And this data is stored that as an insertion and deletion occurs only at the top level, only at the top, not top level, only at the top index. And we'll be having push, pop and peek operations that all will take O(n) time. And stacks are used in function calls and management and undo operations. The advantage is fast and simple operations, while the limitation is restricted access to only the top elements. Now coming to queue data structure, it's also a linear data structure that will follow like first in first out element, whichever comes in first that will be taken out first. Insertion happens at the rear and the deletion happens at the front, and like it will be having enqueue, deque and front access operations like in that they will be taking O(n) time. And queues are used in task scheduling and printer queues. Like the advantage is maintaining order, while the limitation is like random access. And coming to deque, it is also known as double-ended queue. It will be allowing insertion and deletion at both the front and the rear. Insert and delete operation at either and take O(n) time, and accessing the front or rear element also takes O(n) time. Deques are will be used in like sliding window algorithms and scheduling algorithms. The advantage is like flexibility in access, while the limitation is increased implementation complexity.